hard and soft water. We know water which we can get out of the from the distillation process is called distilled water, and that is said to be the purest form of the water. Rainwater is also almost 99% is pure, and when it falls down, it actually means the universal solvent makes a lot of salts to become soluble in it. That is why usually the water sources, whatever we are having, like rivers, ponds, and other freshwater sources, are found to be having having lot of salts dissolved in it. Now this water is of two types: hard water and soft water. Hard water, we call it a water which contains which contains bicarbonates, carbonates, sulfates, and chlorides of calcium and magnesium ions. Now these salts makes the water hard, and the sample in which they are found to be not present are said to be soft water. Now hard water, usually the hard water doesn't give rich lather with soap, whereas the soft water, which doesn't contains these salts, is free from these salts, and it gives rich lather with soap. Now the problem comes is that we are not able to wash our clothes properly in hard water. The reason being, these salts combines with the soap molecules, like I am taking example of C17H35 COONA. This is called sodium stearate, stearic acid sodium salt, because this is what a soap is. When it is actually being taken in hard water, these calcium or magnesium ions of the hard water displaces sodium ion, and they forms their corresponding salts with these long chain fatty acids like this. Now this is called calcium stearate. Now this is insoluble in water. This is insoluble in water, and it forms scum on the water. That is why it doesn't give a good cleaning action. It doesn't show this type of molecule will not be able to lead to the formation of measles. Therefore, what will happen is the soap will not be able to show its cleaning action. That is why we say that in hard water it becomes very, very difficult to wash the clothes. And the other problem is it comes in the case of boilers. Whenever we are using a hard water in the boilers, these salts settles down and they forms a scale on the boilers, and that reduces their efficiency. So that is why we need to remove these hardnesses, and we have to convert the hard water into a soft water in order to make it more important, useful for industrial purposes. So that is why we remove these hardness. So actually meaning of hardness is the presence of these impurities or these salts in the water. Now this hardness is of two types. One is called temporary hardness. Now temporary hardness is due to bicarbonates of calcium and magnesium ions, and permanent hardness is due to sulfates and chlorides of calcium and magnesium ions. So that's the differences. This can easily be removed. It becomes very difficult to remove this permanent hardness, but we need to know the methods of removing the hardness of water. Now let us understand the methods of removing these hardnesses. The temporary hardness can be removed by two methods. The first is called boiling. What we do is, the water which is said to be what hard water, having what magnesium bicarbonate, on heating, on boiling, results in the formation of magnesium hydroxide, water and CO2. So what happens is, this magnesium hydroxide settles down, forms precipitates, and is easily being actually filtered out. In a very similar way, calcium bicarbonate, when actually he is heated to boiling, leads to the formation of what precipitates of calcium carbonate along with some water and CO2. Now this calcium carbonate being settles down, forms precipitates, and is easily being what filtered out. The second method of removing the permanent hardness of water is called temporary hardness of water is called Clark's method. Clark's method. Now in this calculated amount of lime calcium hydroxide is added. Now how it makes differences? Like if we are having calcium bicarbonate and it is actually being reacted with calcium hydroxide, what happens is it leads to the formation of calcium carbonate, which gets what filtered out, it forms precipitates which is being filtered out. And if we are having what magnesium carbonate as the source of hardness of water, and we know that what we are doing is we are adding what lime into this, it leads to the formation of calcium carbonate along with the formation of magnesium hydroxide, and small amount of CO2 and H2O is being CO2 remains in this, it is H2O. And what happens is these the calcium and the magnesium salts are being precipitated out as they are what carbonates and hydroxides, and these are easily being filtered out in order to make or convert hard water into a soft water. Let us see the methods of removing the permanent hardness of water. We have mainly three methods of removing the permanent hardness of water, and the first method is by using washing soda. Washing soda sodium carbonate, when combines with these metal ions, chloride or sulfate form, converts them into their corresponding carbonates, which in the form of which they get filtered, precipitated out and easily from the water, and this is how we can make a hard water soft water free from these metal ions. I'm repeating again, the chlorides and the sulfates of these calcium and the magnesium ion, when combines with sodium carbonate, they get precipitated out as their carbonates, and this is how the hardness can be removed, and we get NaCl or Na2SO4 that remains in the solution. The second method is called Calgons Method. In this we use a sodium hexametaphosphate. The formula is Na6P6O18. Now this compound is in common language is called Calgon. Now when this is added to water, it loses two sodium ions and it has 2 Na plus, and it becomes Na4P6O18 2 minus. Now this Calgon in the form of this ion in the form of which is there in the water shows ion exchange method, and what happens is two sodium ions of this Calgon gets replaced by what the calcium or the magnesium ion, which I have taken as N. And this is how they form Na2MP6O18 2 minus, and in place of those two the metal ion which has been accepted, the calcium and magnesium, two sodium ions comes out in the solution. So Calgon is basically showing an ion exchange in which the exchange of the sodium ions with this metal ion is taking place, and this is how these metal ions, calcium and magnesium ions, becomes a part of this Calgon, and then they remains in it, and it is being in this form they can be taken out. In water filters, what we use the sieve, which is also already having these Calgon, and this is how these hard calcium and magnesium ions, which are mainly responsible for the hardness of water, are easily being removed. The next method of removing the hardness of water is called ion exchange method. In this we use what sodium aluminium silicate, NaAlSiO4, this is also called zeolite or permutate. Now they show again the ion exchange method in this this meta-aluminates, aluminosilicates we are having, out of these molecules, the sodium ion which they are having gets exchanged by the calcium or the magnesium ions of the hard water. So where I have represented this Z in this form, this is said to be your Z. So I'm writing this NaZ when it is actually being treated with this hard water which is having M2 here is your calcium ions or magnesium ions. Now what happens is this M replaces sodium and it again forms its own salt with these zeolites, and the sodium ion gets gets into the solution, and this is how the ions which are mainly responsible for the hardness of water are being removed in the form of their calcium or magnesium salts of these aluminosilicates from the solution. The next method of removing the permanent hardness of water is the synthetic resin method. In this we uses the artificially made synthetic resins or large organic molecules which are having the sulfonic group. So I'm writing ion exchange resins as RSO3H, alkyl sulfonic acid groups. Now these are converted into their sodium salts by reacting them with sodium chloride solutions. So what we get is RSO3Na, which is commonly written as RNA. So these are your normal common your organic synthetic organic resins. Now they show cation exchange, that the sodium ion, the cation which they are having, gets easily being exchanged by the calcium and the magnesium ions, like which are represented as M2 plus, as R2M, and this is how the solution the sodium ions comes out in the solution, and these are the calcium and the magnesium ions are easily being filtered out as the precipitates or insoluble parts. Now this is how the cations are being removed. In a very similar way, the anions are also removed, because we write the alkyl resins as which are exchanging anions, not the cations, as RNH3 plus and OH minus. They combines with the X minus ions, which can be mostly the chlorides or the sulfates they can have. Then what happens is their own salts RNH3 plus X minus is formed, and in OH minus comes out in the solution, and this is how they get filtered out, precipitated out, and they get separated out easily. So this is what is the synthetic resin method of removing the permanent hardness of water.